Okay, so hope all of you have got a chance to go through all these questions once more after the test. But anyway, let's do a discussion of them now. Yeah, we'll discuss all the questions. Don't worry, Varun. So let's start with this one. Yes, you have to submit all the assignments in the Google Drive folder. Okay. Previous means like whatever you're doing from this week onwards, you submit. Not necessary that you have to submit all the vectors and all that assignments, because that might be very difficult doing so many assignments submission together. But whatever at least you're doing in last couple of weeks in a current topic, try to submit everything. Okay, so let's figure out. Well, let's start with the first question here. So see, what is happening in this case is that it says that the system is in equilibrium. Okay, so that means all the blocks are at rest. Okay, so this block is at rest. This block is at rest. Okay, so now if this particular string is having some tension T1, that tension is acting like this. Okay, so your first equation will be T1 is the weight of the block Q. Okay, so mass of the block Q is given as 25. So this is 25G. First equation. Okay, then let us say the tension in this string from this knot B to this is T2. Okay, and the tension in this string here is T3. Okay, so what is happening is the second block is at rest also. So T2 is equal to mpg. Okay, so this is what we want to find out. Okay, now you look at this thing, the equilibrium of the point B, or that the net force at the point B should be 0. So at the point B you can see that tension T1 is acting from this side like this, tension T2 is acting vertically below, and tension T3 is acting horizontally from this side. And what else is given to us is that this string between the point B and the pulley is at 53 degrees to the horizontal. Okay. So that means this angle here is 53 degrees. So you can either resolve or you can use Lami's theorem or whatever. Okay. If you resolve this situation, you will get this, that when you resolve this force, you will get T1 sine 53, T1 cos 53. Okay. So T1 sine 53 balances T2, which is the weight of that. Okay, so T1 was 25G and sine 53 is 4 by 5, and this one has to be equal to mass of P into G. So from that you can see that mass of P will become equal to 20. Okay. Okay, so Varun, hope this is clear, and everybody else also. If there's any doubt in any step, please let me know. Now here you could have also used Lami's theorem. You would have got the same result. Yes, people, any doubt in this? ये तो resolve किया ना T1 को. Archit, you didn't understand. That's why we've resolved T1 na, into components. See in this diagram, that's why we've resolved T1 na. This is the cos component. This is becoming the sine component. That's how we resolve this force. That's what we've done between this step and this step. Okay, so hope this is all clear. Let's move on to the next question. Okay. Anybody has a doubt in the second question? Oh, Salman. Okay, how it equals? Because they are balancing, na beta. The net force is zero. Okay. Yeah, okay. I'll come to second question. Salman, in the previous question, what is happening? The net force at this point is zero, na? That point B is stationary. So ये वाला जो point है, इस पे क्या होगा? नेट फोर्स जीरो होना चाहिए. सो ये फोर्स और ये फोर्स तीनों मिलके दे शुड गिव रिजल्टेंट ऑफ जीरो, बिकॉज दिस पॉइंट इज नॉट मूविंग, इट्स एट रेस्ट. So the vector sum should be zero. You understanding? Okay. Okay, let's come to the second question. So anyway, the correct answer in this was D. Okay, that's that option. Okay. Okay, let's come to the second question. Now you have to find this all the surfaces are smooth. Okay, and thread is massless and all that. The pulley is smooth. E and B are of identical mass. That is the important thing. Okay, and the surface is smooth. Okay, so you can see that this is a steeper slope. You know, so logically, even though their mass is same, but this one will tend to accelerate down the inclined plane, and this one will tend to accelerate up the inclined plane. First of all, okay. Now to find that acceleration, just make the free body diagrams of A and B. So in the free body diagram, you have to understand that there will be tension in the thread acting like this. Okay. There will be weight of each of the blocks. This is mg, same weight. Okay. but normal reactions will be different. Why? Because the angles are different. So this is experiencing some different normal reaction, let's say N1. This is experiencing a different normal reaction, let's say N2. Okay. So now you come to individual free body diagrams. So for the block P or A, whatever, you can see that if you resolve the forces, okay, so mg के components कैसे हो जाएंगे? There will be mg cos 37 in this direction and mg sin 37 in this direction. Okay, there is tension. This is having an upward acceleration A. So for the block A, the net force equation will become what? T minus mg sin 37 degrees is equal to ma. That's our first equation. Okay. Now similarly on the other side, if you look at block B, so hope the resolution of forces is clear. Okay, resolution of forces is just coming from this concept. You are aware of this. On an inclined plane, if this angle is theta, then this angle becomes theta. So that is why when we resolve this force mg, the component into the plane is always mg cos, and the component along the plane is always mg sin. Okay. So this free body diagram situation I told you to keep in mind always. Okay, for an inclined plane situation. So anyway, let's come to the other free body diagram for the block B. So the block B is on a steeper inclined plane. This angle is 53. So now if you look at the forces for it, you resolve mg. So mg का ये component कितना हो जाएगा? mg cos 53 degrees, and the component along the inclined plane will be mg sin 53 degrees. And trying to oppose this is tension. Okay, but as you know, because it will move down the inclined plane, because this force will dominate. Okay. So for the block B, we have the equation mg sin 53 degrees minus tension is equal to ma. Okay. So these are the two equations we need to solve. Of course, there is also the equation for normal reaction, but that is not required for solving for acceleration. So you have that N1 will just balance mg cos 37 here, and N2 will just balance mg cos 53. But these two equations are not going to help us solve the problem, because we need to find the acceleration. Okay, so this equation becomes T minus 3 by 5 mg is equal to ma. This becomes okay. So now we can just add the two equations, so we get rid of T, and we have 4 by 5 minus 3 by 5 mg is equal to ma. Sorry, 2 ma. Let's just write it like this. Okay, so 1 by 5 mg is equal to 2 ma on the other side. So E is becoming g by 10. Okay, and it is in such a way that this block is accelerating upwards and the other block is accelerating down. So we'll have to select the option accordingly. So hope the free body diagram equation is clear. Just drop me a message in case you have any doubt with anything. Ritika, you understood the question, beta? Okay, good. So finish writing this and quickly, and we'll move on to the third question next. Yeah, Sarvesh, how to determine which is going upwards and which is going downwards? See, for that you have to understand na, कि this one was being pulled by, see, इस पे जो component of weight down the inclined plane है वो कितना है? It is mg sin 53. Okay, और इस पे कितना है? It is mg sin 37. Okay, now you know that sin 53 is greater than sin 37. Okay, so therefore you know that B will accelerate down the inclined plane and E will accelerate up the inclined plane. Okay, the other thing is, like, you, if you can't understand this directly in the problem, you just assume some direction of acceleration and solve. If your assumption is correct, then you will get the acceleration with positive sign. If your assumption has to be reversed, you will get the acceleration with negative sign. So that is the important thing here. So in this case, the correct answer would have become this one. This accelerates up the inclined plane, B accelerates down the inclined plane, and the acceleration's magnitude is g by 10. Okay, so third question, unfortunately, the question had not appeared fully in the test. So that test has been removed, that question has been removed from the analysis. So if you like, you can note down, this is the full question actually. Okay. So you have to, so basically what is given to us is that now we don't know the masses, so we don't know which one is going up and which one is coming down, but let's make some assumption. If this is coming down with A1, this is going up with A2. Now I've told you a couple of methods how to find the ratio of A1 and A2. Thread length conservation, you can use that, or you can use virtual work method. Both the methods I've taught you. So this is experiencing. So on this block the tension is 2T, on this one the tension is T. So if M1 is coming down through a displacement of x1, okay, and on M2 the displacement is x2, while the tension force acting is 2T. So on this, the net work done by tension in the system should be 0. So minus 2tx1 here plus 2tx2 should be 0. So x1 should be equal to 2x2. So differentiate this twice. So e1 should be equal to 2a2. So e1 is 2a2. This ratio is 1 is to 2. However, this question has got cancelled from the test because for whatever reason the print had not appeared fully. So I think the question was just up to here or something. So we did not know what to calculate in the question, but this is the correct answer. Sorry, this is 2 is to 1, not 1 is to 2. Okay, so hope this question is clear, people. Ritika and Sarvesh, both of you. Okay, good. This was an easy question, unfortunately, because of technical mistake in the test paper website, it got cancelled. Okay, now fourth question, little bit tricky. Okay. So tricky because you have to understand what the question is saying. So the condition for the question is that this thing is happening. Okay. You have to find the value of m1 so that the 100-gram block remains at rest with respect to the ground. Okay. So let's say the tension in this string is T1. Okay. So in that case, the tension in this string T2 will become 2 times T1 first of all. Okay, because that you can see from the free body diagram of the pulley P2. It's a massless pulley, so इस पे net force 0 होना चाहिए. So that's the first equation, how we are getting that. Okay. Now secondly, the 100-gram block is at rest. So we have to make use of that. Okay. This one, this block here, it is at rest. Okay. So if this one is at rest, then okay. Or you can write it as 0.1 g whatever. So this is our second equation. This was our first equation. Okay. Now you have to understand that if this block is at rest, what kind of constraint relation it will develop. Okay. So So imagine this one is at rest, but now suppose this is coming down at some acceleration a1 and this is going up at some acceleration a2. Okay, so after some time this block would have reached here. Okay, so this has come down through an acceleration, I mean through a displacement of x1, let's say. Now during that time this pulley would have gone up by that same displacement x1, because this total thread length is conserved. Okay, and this block would have gone up with some displacement x2. So one thing is you can conserve the second thread length. So if you conserve the second thread length, you will get this equation for this thread L. In the second diagram, this pulley is going up, ना? It's going up by x1. So यहाँ पे और यहाँ पे extra thread आ गया. So this is plus 2x1. But this block is also going up. So it's okay. So this should balance. Okay. So this is showing you that x2 is equal to twice of x1. That is one way. Okay. Or another way is the virtual work method. The net work done by tension should be 0. So on this block you can see how much tension is acting on 200 grams. Only T1 is acting. Okay, so T1 into upward displacement x2. On this block how much tension is acting? T2, but it's having a downward displacement, so this should be 0. And we have already that T2 is equal to twice of T1. Okay, so T1 x2 minus 2 T1 x2, sorry, x1 should be 0. So in this question it's really a matter of your choice whether you want to use virtual work method or you want thread length conservation. Okay, the net work done by tension is 0, that is virtual work method. Okay, so now all you have to do is solve. You got the relation between, so x2 and x1, whatever relation is giving, whether you use this or this, it will tell you that E2 is equal to twice of A1. Okay, so that is your first equation. That's your next equation. That okay. Now you just solve this. So So for the block 200 grams, now you can see the net force upwards. So we have T1 minus 0.2 G is equal to 0.2 A1. Okay. So obviously you can see here that A1 will become a negative quantity because you have written above that T1 is less. It's 0.1 G. So you'll substitute that. But anyway, and for the M1 block, your free body diagram will be like this. So that's your final equation. Okay. So now you substitute A2 as twice A1 and you substitute T1 as 0.1 G in equation 3 and 4. Sorry, in equation 4 and 5. Substitute these things. No? So T1 is, so on substituting, this becomes 0.1 G minus 0.2 G is equal to 0.2 A1. So A1 will come out to be minus of G by 2. So that means A2 will also be negative because it's reversed in direction. So you substitute accordingly. Only this should be A2. So A2 is this much. Okay, so is this question clear or should I explain it in more detail? Okay, I'll repeat the thread length. Just a minute. Just a minute. I will switch screens so I can explain in more detail. Okay, so let's look at this question 4. Okay. So you want to find the value of m1 so that the 100-gram block is at rest. So first of all, let us find the constraint relation. Okay. So the constraint relation is this one is at rest. So after some time, this remains here. Okay. But if this block, for example, we were assuming it's come down. So it has come down by x1, then this pulley would have also gone up by x1 only. Okay. And this block would have also gone up by some distance, let's say x2. So see the total length of this thread ना. ये थ्रेड में क्या हुआ, ये वाला पार्ट सेम है बट यहाँ पे और यहाँ पे ऐड हो गया है ना. सो इट इज 2 times x1 has got added, but also this has gone up, so x2 has got subtracted. So this has to be equal to the original length. Okay, so this is the length of this thread. This is the method. Is this clear now, Rahil and Sarvesh? Okay, I'll explain again, Sarvesh. Seem to be having some difficulty with thread length. Okay, anyway, doesn't matter. Okay. So this one remains at rest. Now I'm assuming that if this one is coming down, this one has to be going up. So after some time, how will our new diagram look like? This pulley is fixed in place. Okay. But this block has come up now. Oh, sorry, has gone down. So this block, suppose, has reached here. Okay. You can see that this is how the downward displacement of x1. So this total thread length is conserved. So this pulley has to come up. So this pulley would have come up somewhere here. This displacement is also x1. Okay. But this has remained the same. This block has not moved. This block is remaining where it is. So this block will have to compensate by going up quite a bit now. It's clear now, Sarvesh? Now compare this thread length with this thread length. So यहाँ पे ये वाला part अगर L1 था और ये वाला part अगर L2 था, so L1 plus L2 was the total thread length. So on the right hand side, what is happening? This part it is becoming L1 plus X1, and on the left hand side, this is becoming L2 minus of X2, that is this much part, but plus of X1. So this also has to be total length. So compare the two sides. So you can see that X1 and X2 have this kind of relation. Is it clear now, Sarvesh? Okay. So differentiate this. Okay, good. So if you are assuming this one has a downward acceleration, this one has an upward acceleration. Oh, sorry, this one is at rest, my mistake. Okay, so we have, okay, this, and then you have the free body diagram equations. So we had assumed the tension in this string to be T1. The tension in this string had become 2T1 because of the massless pulley. Okay. So in M1's free body diagram, you can see that M1G minus T2. Okay. Or you can write this as M1G minus 2T1 is equal to M1E1. Okay. Then in the 100-gram blocks free body diagram, you can see that T1 balances its weight because acceleration is 0. So T1 is becoming 0.1 g. Okay. And you can see the 200-gram block, its equation is going up, I'm assuming. Okay. So tension minus wait, this is the fourth equation. Okay. So what you do here is you want to compare it with this equation. So T1 minus 0.2 g is equal to, now substitute A2 as twice A1. Okay. So we're getting the equation that T1, which is 0.1 g, minus T2, which is 0.2 g, is equal to 0.4 A1. So we will get A1 as a negative quantity. So this means that actually the 200-gram block is coming down. So when you substitute this over there, it means E2 should also be negative. It should be minus G by 2. Okay. So that means that actually A1, instead of going up, it is coming down. So our directions has to be reversed. Okay. So A1 is going up, A2 is coming down. like this. Okay, the minus sign only signifies that. But now we have to find out the value of m1. So substitute this in equation 2. Okay, so m1g minus 2t1, that is 2 into 0.2g, has to be equal to m1a1, which is minus g by 2. Okay, so m1 minus zero point 0.4 is equal to minus m1 by 2. So 3m1 by 2 is equal to 0.4. Okay. This is in kg, you can convert it to grams. So you get the answer. Oh, sorry. This is A1 only, na? So this is, yeah, this is fine. This is g by 2, but only in this equation it's A1. So we have to substitute g by 4 here. This equation is A1. Just a small correction here. Wait, again I made some mistake in substitution. Wait. The equations are all fine, just a matter of substitution. So in this equation, we have to substitute T1 as zero point 0.1 g, and we have to substitute A1 as minus g by 4. So let's do that properly. So m1 g minus 2 times 0.1 g is equal to m1 into minus g by 4. Now let's cancel the g on both sides. So m1 minus zero point 0.2 is equal to minus m1 by 4. So 5 by 4 m1 is equal to 0.2. kg. Okay. So when you convert to grams, 1000, 160 grams, 800 by 5. So this will become the answer. Okay, so this question I'm also showing you how even if I've assumed the direction of acceleration to be wrong, the equations will show me that the minus sign will show me that the direction is to be reversed. So what is happening in the question finally is that this block, instead of coming down, is going up at an acceleration of g by 4, and on the other side this block is at rest, while this block will be coming down with an acceleration of g by 2. Okay. So for that to happen, this being 200 grams, this being 100 grams, this will have to be 160 grams. Okay. And of course this pulley will also be coming down. Okay. But this one will be at rest. So this is the final conclusion of this problem. So I told you this was one of the tricky questions in the test paper. Okay, people, so hope all the steps are clear. Let's go back to the test paper. Yeah, so that was question number 4, and the correct answer was 160 grams. Let's move on to the next one. This is a comparatively easy question again. Now you have to find the tension in the string connecting B and C. No. So here, just a second. Yeah, so over here, we just take the tension in this string as T1, the tension in this string as T2. You understand that these blocks will both be coming down with an acceleration A, and this will be going up with an acceleration A. So you make the free body diagrams for block A. Okay. For block B on the other side, and for block C, T2. So your equations become like this. For block A, you have T2 minus mg is equal to ma. For block B, you have, oh wait, I mixed up the tensions. The tension in this string is T1 and that one is T2. So this upper string is applying T2 B and the lower string is applying T1 this one. Okay. Yeah, so for block B we have the equation T1 plus mg minus T2 is equal to ma. And for block C we have the equation mg minus T1 is equal to ma. Now from this you have to find this tension. You have to find tension T1, tension in this string. So first you can just add the three equations. So T2, T2, T1, T1 will cancel and we will have 2 minus 1, that is mg on the left hand side is equal to 3 times ma. So G will come out to be, A will come out to be G by 3. Now substitute this in the equation 3. Okay. So you have mg minus T1 is equal to ma. So that's mg by 3. So T1 is equal to 2 by 3 mg. And then substitute the value of G as 9.75. So you will get the correct answer. So 2/3 of 2 kg multiplied by 9.75. So that will become 4 times 3.25. So 13 newtons will become the answer. So hope this question is clear to people who have asked. Right. So Sarvesh, this is clear to you? Okay, good. So let's move on to the next one. Okay. So in this question, they've asked you to find the net force, okay, exerted by the pulley on the clamp. So what you have to understand is that the string has some tension. Okay. So now understand the free body diagram of the pulley. Okay, so on the pulley, there is tension acting like this, and there is tension acting like this. Okay, and the pulley is massless. Nothing is given about the pulley's mass, so we have to assume it's massless. So net force on this has to be zero, ना? So ये दोनों मिलके they are pulling it in this sort of direction. So the clamp has to apply a reaction force like this, and that is the force with which the pulley is pushing the clamp. Okay, so here R is the reaction force, okay, on the pulley by the clamp. So it's equal and opposite to the reaction force on the clamp by the pulley. So clamp पे जो है pulley ऐसा force लगा रहा होगा, must be applying an equal and opposite reaction force because the clamp is applying force like this on the pulley. So anyway, so as you can see in this diagram, this tension and this tension are perpendicular to each other. So that reaction force will balance the vector sum of these two tensions. So it will become T root 2. Okay. And to find T, you have to just understand that this is accelerating like this. This is accelerating like this. So you have mg minus T is equal to ma. So from this you have mg by 2. Okay. So substitute this here. So that becomes your answer. V becomes your answer. Hope this is also clear then. Okay. Pulley is massless, beta. We don't have heavy pulleys in our syllabus, so pulley is massless. So even if the question doesn't give you anything about the mass of the pulley, you have to assume that it's an ideal pulley. Okay, so sixth is done. Now seventh question. So seventh is just about understanding the relationship between the tensions. Okay. Okay. So in this question, see, what you have to understand is key. Whatever force you are applying, that is becoming the tension in this thread. So T is equal to F. Okay. Now that tension is acting in this way everywhere. Okay. Now there's also some different tension in this thread. Okay. Let's say that's T prime. So from this pulley, let's say this pulley is P1. So from the free body diagram of P1, you can see that okay, T prime is equal to 2T or T prime is equal to 2F. Second equation. Now you look at the free body diagram of the block B with the pulley attached to it. I guess. So ये सिस्टम पे नेट फोर्स कितना लग रहा है? T prime T and T. Okay, and of course weight of the block. Okay, so if this is at rest, then T plus T prime plus T should balance mg. So 2T plus T prime should balance mg. So that's your third equation. Now substitute from these two. Okay, so that is becoming 2 times F plus 2F. So the amount of force we should apply should be 1/4 the weight of the block. So whatever the weight of the block was given to you, I think it was 100 newtons. So this should become this. Okay. So is this clear? Ritika, is the question clear to you? You have asked this question, so okay, good. Okay. Now in the above question only, if we change the force to 30 newtons, then what will happen? T will be 30 newtons. Okay. T prime, which is twice of T, will become 60 newtons. So when you look at the free body diagram of the block B, okay, okay, this is acting. So this will now have an upward acceleration of all these forces acting. Yeah, I'll come to those questions. Okay. So as a result of that upward acceleration, I mean, as a result of this, the net force on it is 2T plus T prime minus mg should be equal to ma. So substitute here. So 60 plus 60 minus 100 should be equal to 10a. So 20 should be equal to 10a. So it will have an acceleration of 2 meters per second square upwards. So the answer should be this. Okay, so hope this is clear to all of you. Yeah, Ritika, you've asked the 9th question, so we'll discuss that next. So in question 9, what you have to understand is कि ये इस पे जो force लगाएगा, this will be like this. This normal reaction will be perpendicular to this. Okay, but along with that, there will also be a normal reaction that the floor is applying on the plank. That is, let's say n prime, and there will be the weight of the block. I mean, weight of the plank, mg. So in the free body diagram of the plank, there are all these forces acting. There is mg. There is this horizontal force acting at the bottom, F, like this. Okay. There is one normal reaction acting at this point like this, and one normal reaction acting from the floor like this. Okay. Now the main thing is about the angle. You can see this angle is 60 degrees. So this angle is 30. So this is 60. So this angle will become 60 degrees. Huh? Or this angle will become 30 degrees because this is 60. Okay. So now balance the forces. Net force has to be 0. So along your x-axis, क्या हो जाएगा? N cos 30 has to balance F. So root 3 by 2 N has to balance F, which is given to us as 200 newtons. So this normal reaction is 400 by root 3. And about the vertical, you don't have to worry here because the other normal reaction has not been asked. But if you take along the vertical, you will see that n prime plus n sine 30 together has to balance mg. Okay. So n prime plus n by 2 has to balance 500 newtons. So this would have given you n prime. यहाँ से n substitute करके फिर n prime आता है. But this is not required because what has been asked is only n. Find the contact force at the corner point of contact with the fixed wall. So this n you have to find out. The question clear, Ritika? Okay. Now next we'll move on to question 14 because I think the other questions are clear to you. You have not. All these questions are pretty easy. This one, this one. Okay. So question 14 is actually directly a question from H.C. Verma. But anyway, doesn't matter. We'll discuss. So this one will be coming down. This one will be going up with the same acceleration. This one will be going up because this one's mass is more than this. So let's say this tension is T1 and this tension is T2. So now just make the free body diagrams of each of the blocks. So the 50-gram block, say G, okay, and there is T2 is going up with an acceleration. So we have T2 minus M1G is equal to M1A, where M1 is 50 grams. Okay. Then the 100-gram block is M2G. This is accelerating like this. Now the other forces acting on it are T1, T2, and some kind of normal reaction. Okay. Now this angle is 30. So here this angle will be 30. Okay. So the net force along the inclined plane, when you write for it, will become T1 minus M2G sine 30 minus T2 is equal to M2A. So that's our second equation. And similarly, now on the other side, there is this block which is 500 grams. So our third equation is M3G minus T1 equal to M3A, where M3 is equal to 500 grams. Okay. Now just add the three equations. So you'll get rid of T2 and T1. T2 minus T2, T1 minus T1. So on adding the three equations, you will get something like this. M3G minus M2G sine 30 minus M1G so M3 minus M2 by 2 minus M1 G is equal to M1 plus M2 plus M3 E. Now since both sides you have mass, you can substitute in grams. The unit will just cancel out. So this will become on the left hand side 500 minus 50 minus 50. Now on the right hand side 500 plus 100 plus 50 E. So E will become 400 divided by 650 G. So that's this thing 8 by 13 G downwards. So is the solving clear, Ritika? Okay. Okay, sir, we shall explain the 13th question also. Okay, I'll come to 13th and 15th, both of them. Okay. So in this question, this is also a lengthy question. So what you have to understand first of all कि ये वाले string में अगर tension T है, so on this string the tension will become 2T. Okay. And therefore in this string become 4t. Okay. So if you now come to the block B's free body diagram, on that there is tension of T double prime, T prime and T. And whereas on the free body diagram of A, there's only this. Okay, understood now? Okay, so now if you assume that the block B is going up with some acceleration A2 and E is coming down with some acceleration A1. So after some time, if B goes up through a displacement of x2, whereas E comes down through a displacement of x1, the net work done by tension should be zero. So on this, okay, and on this you have negative work done. Okay, so 4t plus 2t plus t. Okay, so you'll see that x1 is equal to 7 times x2. So this will give us a constraint relation that E1 is equal to 7 E2. Okay, and then just make the FBD equations. So for the block A, you have weight minus T is equal to mass into, now write this as 7A. And for the block B, you have 7T minus weight is equal to mass into acceleration. Okay. Solve these two equations, you will get the value of E. So from that you will get acceleration of this one is A, whereas acceleration of this one is 7A. Okay. In any case, I think here what was happening is the acceleration of this one was given. So you have to find the acceleration of this one. So that is coming directly. Okay, so let's finish the 15th question next. Okay. So 15th question is also a similar thing, little bit complicated, but understand it this way, that if the tension in this string is T, okay, then the tension in this string becoming 2T. Okay. So on the block B, because this pulley is attached to it, how much tension is acting? Okay. So basically on block B, there's a net tension of 60. Okay. Whereas on the block A, there's tension T only. Okay. So the block A is having a displacement in this direction of x1, and this is having a displacement in this direction of x2. So you have minus tx1 plus 6tx2 has to be 0. So x2 has to be 1/6 of x1. So a2 has to be 1/6 of a1. Okay. So 1/6 of 18. So 3. Is this clear, Ritika? Okay. So that completes the doubts of the major test. Now, just few minutes I'll take more, because I want to discuss the concept of spring force. Just it'll take another 5 minutes. That way we'll finish Newton's laws of motion theory wise today. We'll move on to friction in the next lecture. So an ideal spring has two important properties. It's massless or very light. And the second thing is that it acts as per something called Hooke's law. Now let's understand Hooke's law. That's the important thing over here. Hooke's law basically says that when a spring is deformed, that means it is either compressed or expanded. Okay. So this is an ideal spring now. Okay. Now suppose the length of the spring is L. Now from this state, suppose we take it to a state where it is either got stretched out because we are applying force like this. So now the length has become L plus X. So this is in a state of extended or extension, or it might be in a state of compression because we are applying external force like this. So the thing is, whenever a spring is deformed, that either compressed or extended, it develops an internal tension which opposes its deformation. Okay. So it will develop a tension. In this case, it will develop an internal tension which acts like this. So it opposes the deformation. It tries to bring it back to natural length. In this case, it will develop an internal tension which is acting like this, outwards. But again, it's opposing the deformity and trying to bring it back to natural length. Okay. So just write down up to here first, then we'll discuss more about Hooke's law. So basically, if this is a natural shape of the spring, from here, if it is getting extended because of external force, it will develop an internal tension which is like this. Because it has got extended, so now it tries to come back to its natural shape. Similarly, if it has got compressed, it will develop an internal tension which is outwards. Okay. So that's part of Hooke's law. So it develops an internal tension such that, now very important, this tension is directly proportional to x. Okay. So this tension, or this is also called restoring force, because it tries to restore it back to the natural shape. So this is directly proportional to the amount of deformity. Okay. So that is the compression or extension x. Okay, so this is the statement of Hooke's law, that whenever a spring is deformed, it develops an internal tension or a restorative force, and that restorative force is such that it is directly proportional to the amount of deformity. Okay. So now the constant of proportionality, that is called the spring force. So this tension is proportional to x, where k is called the spring constant. So k is a physical property of the given spring. Okay. So it depends on the material with which the spring is made. Okay. the thickness of the wire. By material we mean metal, which metal is used. Okay, the thickness of the wire, okay, the shape of the spring, all these things. By shape we mean length, okay, radius of each turn, etc. So K is measured in newtons per meter. Okay, so let us just understand this with a quick example. Okay, so if G is equal to 10 meters per second square and the natural length of the spring is 20 centimeters, then find tension in the spring, the extension in its length x, okay, and its total length in this case. So what we'll observe here is that the weight of the block is pulling the spring down. So the spring is applying an tension like this. Okay. So if you look at the spring state, it is being pulled downwards by mg, some kind of reaction force. Okay. So it's developing an internal tension which is like this. Because what has happened is, as a result of this, it has got extended. It has become L plus X. Okay. So this tension will be equal to the weight of the block. Okay. So Kx is equal to mg. So the first part, the tension is 120 newtons. So second part, excuse me, this tension is Kx. So x is 120 newtons divided by 50 newtons per centimeter. So that is the value of K which is given to us. Okay. So the extension will be 12 by 5 or 2.4 centimeters. Okay. And C part, the length will be L plus X because it's in an extended state, you can see. So natural length was 20, so it will be 22.4 centimeters. So in this situation, the spring will be seen to be stretched to a length of 22.4 centimeters because of the weight of the block. Okay. So this is the basic concept of the functioning of a spring. Okay. And with this now you can complete the problems based on springs also in H.C. Verma in your module. Just a few questions are there, not too many. So we'll complete the discussion of that in the next lecture, and then we'll start with the next chapter, which will be friction. Okay. Now really your first target is to now complete H.C. Verma if you've not done that already. So any doubts pending in H.C. Verma, any questions remaining in H.C. Verma, please make sure you finish this week so that you can complete that discussion in the next lecture if required, any questions. And otherwise we will just discuss some questions from the module. Yeah, I will explain that in the next class, Sarvesh. Okay. you have to make the free body diagram of that rope. It's instead of a thread, if you have a heavy rope, you make a free body diagram of the rope, and then make a free body diagram of a section of the rope where you want to find the tension. So anyway, we'll conclude today's lecture here. I will do the discussion of that questions in the next lecture. Okay, so that's it for today, people. Thanks for attending. Continue working on HC Verma questions and also from your module, and look to complete Newton's laws of motion so that we can start friction in the next lecture.